On this example, we're going to graph the equations by using our knowledge about slope-intercept form and horizontal or vertical lines. On the first one, f of x is equal to negative 3 over 2x plus 2. Now this is what we call slope-intercept form. Y equals mx plus b. The m would go along with what we've been working with so far, which is the slope. And b is actually going to stand for the y value of the y-intercept. So slope-intercept form is very convenient for that reason. If we look at this equation in slope-intercept form, the negative 3 over 2 would be our slope m. And 2 would be the number for b, so that would be telling us where the y-intercept would be located. If we'd like to draw a quick sketch of this equation, what we'll do is consider where the y-intercept is, which would be over at the point 0, 2. And then think about the slope as rise over run. In this case, it's a negative number for the slope, so it will be a falling line. So if I go forward 2, the slope would tell me that I'll fall by 3. So forward 2, down 3. And that would result in a second point that we can draw through to get the graph of the line. For this next one, what we're going to do is rewrite it into slope-intercept form by solving for y. So I'm going to start off by subtracting the 3x over. And then we can add the 12. So 6y equaled negative 3x plus 12. To solve for y, we're going to divide through by 6. We can divide everything by 6. That would result in a y equals negative 1/2 x plus 2, once I've reduced the fraction of negative 3 over 6 down to 1/2. So now this is the solving for y, and that puts it into slope-intercept form. We can follow along the same idea from the last example for graphing the line of the equation. Our slope here is negative 1/2, and our y-intercept would be the coordinate 0, 2. And so again, like the last one, the slope is negative, so the line would be falling from left to right. And what it would tell me I can do to find another point, starting from the y-intercept, if I go forward by 2, then it would go down by 1. So that would give us the second point to draw the line through those 2 points. Now these next two equations are not very big, but they have something in common. One is just y equals a number, and the other is just x equals a number. And all we have to know is if we have an equation where it's y equals to a number like b, then that's going to be the equation of a horizontal line. And if it's x equal to a number, then that would be the equation of a vertical line. So to draw y equals negative 3 as a horizontal line, we just go down to negative 3 on the y-axis and draw a horizontal line through that number. For x equals 2, we'll draw a vertical line by going through 2 on the x-axis. Now in this situation, what we're going to be looking at is some actual data points, and approximating what happens when we draw a line through these data points to get an idea of the trend that goes along with them. It shows 2 different lines, one male, one female, for the percentage of never married American adults aged 25 to 29. So we're going to be using the blue line here for the female data set. And since it's, again, the trend for the numbers follows along a straight line, we can create an equation for a linear equation and a linear function that can follow along the trend of the data points. So step 1 is we're going to use 2 points to find the point-slope form of the equation of a line that models the percentage of never married American females aged 25 to 29 in the variable y for x years after 1980. So again, the 2 data points we can use is the one that says 10, 31.1 and 20, 38.9. This can be our x1 and our y1 and our x2 and our y2. The first thing I'm going to use is the slope formula to calculate the slope of the line passing through these 2 points. So that would go 38.9 minus 31.1 divided by 20 minus 10. That would equal to 7.8 divided by 10, which would just be 0.78. Now, in order to get the equation, however, for the line passing through these points, we're going to use the point-slope form. So we'll plug in for y1, we'll get y minus 31.1 equals, for m, 0.78, x minus 10. So for the first part, that's just getting the point-slope form for the equation of the line. We're going to take the equation of the line that we have and write it in slope-intercept form. And we're also going to use function notation when we're done. So what we need to do now is solve what we just wrote for y. So if I distribute the number into the parentheses, it would change it into y minus 31.1 equals 0.78 x minus 7.8. I can then add the 31.1 to both sides. And so the result would be y is equal to 0.78x plus 23.3. Okay, and so now that we have the equation of a line passing through the data points that we have, we can actually take this another step further and make predictions about where the trend will continue into the future. So the function we have here, again, it said to use function notation, and the only thing that would be different is to write it as f of x instead of y equals. So this is what it would look like in function notation. And let's use that to predict the percentage in 2020. Keep in mind that x is the number of years after 1980. So we're starting from 1980, and we know that 2020 is 40 years after 1980. So what we're going to do is use that number for the x equals to 40. So we're going to substitute that in to calculate inside our function. We'll calculate f of 40, which would be equal to 0.78 times 40 plus 23.3. Doing that calculation would result in 54.5. And for our function, that tells us a percentage, so 54.5% of females aged 25 through 29 who never married by the year 2020. So we're making this prediction based again off the linear trend of the straight line passing through those 2 points using the equation of the line created by using those 2 points in the slope formula and in point slope form.